All right, so what we want to do is to look at another one of these problems like we were doing in class today, and hopefully this will help clear up any misunderstandings you may already have. If it doesn't, y'all know where to find me. All right, so we've got an angle in center position. The terminal side is in the given quadrant, and we want to write the remaining 5 trig functions or ratios, another word for it, for theta. So we're given the sine ratio, and we're also given which quadrant we're located in. So I have gone ahead and drawn a terminal side in quadrant 4. When we're doing these problems, we've got to make a triangle because we need a triangle, a right triangle, in order to write these ratios. So remember back to your SOHCAHTOA thing, and a sine is opposite over hypotenuse. Now we've got to get us a triangle down here going too. So we cannot use this big angle that technically would take us from the x-axis to the terminal side. We've got to use the reference angle. So that's why theta is going to be here. We've got to make our triangle. So the reference angle forms 2 of the sides of the triangle. The other side is going to be made by drawing that line up to your x-axis. Okay, so now we've got a right triangle. The right angle is right
everyone
here.
can return to their class at this time. Everyone should be returning to the class at this time.
All right, so now we've been told that the opposite side is 1. So the opposite side of the theta is 1. And then the hypotenuse is 5. It's here. Now, I'm not worrying about the signs or anything right now. I can go ahead and just do this problem and adjust it at the end. Well, we need to know this adjacent side. We got to find that using Pythagorean theorem. We'll just let it be a in our Pythagorean theorem. So a squared plus b squared is 1 equals c squared. That is 5 squared. So let's do some simplifying here. So we are solving for a. We'll square root both sides. So we're looking at the square root of 24. And if you reduce that, it should be 2 square root of 6. Yep, that radical thing just happened. So hang on to that. All right, what we want to do is label what our sides of our triangle are in relation to theta, because we're ready to write the ratios. So here we go. The 1 is going to be across from theta, so that's your opposite side. And then the 5 is your hypotenuse. And 2 squared root of 6 is your adjacent. Let's go ahead and start filling these in. And then if we need to adjust anything, we will. I'm anticipating that happening because of that square root there. So for your sine ratio, we've already got it. So let's just transfer that over. Remember we talked about you should never get that one wrong because it's given. Also cosecant, just flip it. And it doesn't matter which number you put the negative on or if the negative just rests right there in line with the fraction bar, it means the same thing. Just don't put negatives on both because that would imply it's a positive number. All right, let's keep going. Cosine is adjacent over hypotenuse. So that is 2 square roots of 6 over 5. And then let's see, we'll go ahead and adjust the secant from there. Now I can already tell when I flip my cosine fraction, I'm going to have 2 square root of 6 on the bottom and 5 on the top. All right, so if I flip secant, this is what's going to happen. But we know we're going to have to rationalize it anyway, so that's why I wrote it down here to give myself a little bit more space. So rationalize by multiplying by the square root of 6 on top and bottom, and then 2 times that 6 that you'll get from the bottom will give you 12. So this answer is 5 square root 6 over 12. All right, come on back to tangent. Opposite over adjacent. Okay, 1 over 2 square roots of 6. That's another one of those I'm going to have to rationalize. So let's come down here and do a little work. 1 times the square root of 6 is just that. 2 times the 6 you will get again is just 12. So that is the square root of 6 over 12. Now here's what's interesting about this next one. If I were to take my tangent fraction and flip it, that would be 12 over square root 6. And that would be something else I'd have to rationalize. But what you can do is go back to this original tangent ratio we had before we rationalized it. And you can flip that instead. So that would be 2 square root of 6 over 1. So let's just do that instead. And that again would just be 2 square root of 6. You don't really need the 1. All right, but let's say you didn't know you could do that and you did flip that anyway. Here's what you do. You would get 12 square root of 6 over 6. Then you could see, hey, I can reduce that, and it's just 2 square roots of 6. So it's not a tragedy if you don't recognize that from the get-go. I'm just trying to save you a little bit of work if we can. All right, well, we have done the hard part, really. We've just got to go back now and figure out, do we have the right signs on all of our ratios? Well, we're in the fourth quadrant. And remember from your little saying, all students take calculus, that cosine is the only ratio, along with secant, the only ratio that should be positive in the fourth quadrant. That's why sines and cosecants have negatives, and that's also why we're going to add a negative to this tangent and cotangent ratio. In the fourth quadrant, they're negative, not positive. All righty? If you need anything else, let me know.